I want to take a look at two function compositions that involve a trig and an inverse trig function. But this time we're working with the inverse trig function arcsecant, which is one of our newer ones that we haven't spent so much time with. Okay, they're very related. We're looking at tangent of arcsecant of x when x is positive, and then we're looking at tangent of arcsecant of x when x is negative. I think this one's a little bit trickier, so let's work through this one together, and then I'll have you pause the video and work through this one on your own. Okay. All right, so I like to give the inverse trig function a name that makes me think angle. So essentially, we're being asked to evaluate tangent of theta, and I know that's going to be my two-step process. I'm going to figure out the sine based on the quadrant, and then the absolute value based on the reference angle. Okay. With theta, what I know here is that secant of theta is equal to x, which happens to be a negative number for this problem, and theta has to be in the interval from 0 to pi over 2 union pi over 2 to pi. That, of course, corresponds to either quadrants 1 or 2. Now, if x is representing a negative number, which I know because I was told, that's going to put me in quadrant 2. So since that's negative, we're in quadrant 2. In quadrant 2, tangent will be negative. Okay. Then I can say, all right, if I'm in quadrant 2, we've got something like so. I'm going to have an obtuse angle theta. The reference angle I'm just going to call alpha. Now what I know about alpha is that secant of alpha is the absolute value of x. And that absolute value is very important here because since x is negative, taking the absolute value changes the sign. Okay. So I'm going to draw myself a picture of my triangle for alpha. And I'm going to label it with the side lengths. So I'm not doing sine sides because I've dealt with the sine as a separate step. I like to write things as a fraction since this was a trig ratio. Now secant is the reciprocal of cosine. Okay. Cosine would be adjacent over hypotenuse. So secant's going to be hypotenuse over adjacent. Okay. So I'm going to take the top of that trig ratio and make that the length of the hypotenuse. The bottom of the trig ratio becomes the length of the adjacent side. One thing to point out here, if I were labeling things with signed sides, it would not be correct to put an x here because this isn't the side that's negative. The hypotenuse is always positive. The signed side that would be negative, if I were labeling this for theta instead of alpha, that signed side would be this side here. I'd have to have absolute value of x and negative 1 if I were labeling signed sides. X is not the length of any side in this triangle. Okay, excellent. So, looks like I want to find the opposite side. I'm just going to call that P. And let's bump over here and do some Pythagoras. 1 squared plus P squared is the absolute value of x squared. So, absolute value of x squared is just x squared, because when I square things, they become positive anyway. So 1 plus P squared equals x squared. P squared is x squared minus 1. P is going to be the positive square root of x squared minus 1, because P here is a side length. Okay, excellent. So now I can calculate tangent of alpha, and tangent of alpha is going to be this opposite side over this adjacent side. So that's going to be root x squared minus 1. So for tangent of theta, I'm getting negative root x squared minus 1. Okay. Now, remember, when you are evaluating compositions like this, I don't care whether you choose to label side lengths or signed side lengths, but it's not okay to just draw me a triangle. I need to know what quadrant we're in. Okay, so you need to indicate that either by drawing your picture in the appropriate quadrant or by explicitly writing out, we are in quadrant 2. Okay, If you just draw a triangle like so, that suggests that we're in quadrant 1. And if we're not in quadrant 1, I'm going to look for, did you at some point acknowledge what quadrant we're in and take that into account? And you got a 50-50 chance of getting the correct plus or minus sign of things, but I need to see the work to justify that for you to get full credit. So just remember that as you're showing your work. There are a variety of ways to do that. I usually just draw the picture in the appropriate quadrant. Okay, so there's tangent of theta in this particular case. What I want you to do is do it in this case where x is positive. Now, what's nice about x being positive is you're not going to have to worry about any absolute values because a positive number is a legitimate value for a side length. Okay, so I'm going to erase this. I'm going to keep this answer up here, but I'd like you to pause the video, try to work this one out, and we'll see if we get the same answer or not. Interesting question. I've sectioned off this to say this was a problem and this is the answer to that problem. And now the rest of the board I'm going to use to work out this problem. Okay, different problem. We'll see if it has the same answer or not. I'm going to have a similar approach. A lot of the work we're going to do is going to look very similar to what we just did. I'm going to say that that's theta, so we're evaluating tangent of theta, which is going to be our usual two-step process. But what do we know about theta? Since theta is arcsecant of x, I know that secant of theta is x, and I know that theta is in the interval from 0 to pi over 2, union pi over 2 to pi, corresponding to quadrants 1 and 2. But this time, x is representing a positive number. And if it's positive, that's going to put us in quadrant 1, because secant would be positive in quadrant 1. We saw it was negative in quadrant 2. Okay, so I know we're in quadrant 1, which is going to make tangent positive. Okay, all right, and I can draw my picture. Basically, theta is its own reference angle here. And if secant of theta is x, again, I can choose to write that as x over 1 so that it looks like a fraction. That trig ratio has a top and a bottom part. Once again, secant's the reciprocal of cosine. Cosine would have been adjacent over hypotenuse, so this is going to be hypotenuse over adjacent. And we need to solve for the opposite side, which I'm going to call p. Okay. This does look awfully familiar. Last time we just had an absolute value of x there. When I use Pythagoras, that's going to get squared. So I'm going to get 1 plus p squared equals x squared. P squared is x squared minus 1. P would be the positive square root of x squared minus 1. And again, writing that plus sign is not necessary. I'm doing that to remind myself that this is different from just the algebra problem of solving this equation for p, which would have given me two answers, plus or minus. Okay, excellent. So I've got that that's the square root of x squared minus 1. And then tangent would be opposite over adjacent. So it's root x squared minus 1 over 1. And of course, I can just write that as root x squared minus 1. We did not get the same answer that we got when x was negative. We got the opposite answer. So the work was similar. The answers are very similar. They're related, but they're not the same. Now, I mentioned when we were defining arcsecant and arccosecant that our textbook uses the rule that for your second quadrant, for the quadrant in which the trig function takes on its negative values, we never choose 3, we always choose an adjacent quadrant 2 or 4. I also mentioned that that's not the only rule, that some textbooks use a different rule, and that different rule is that if you're working with arcsecant or arccosecant, you choose quadrant 3. The reason is to avoid this problem. If we had chosen quadrant 3, tangent would have been positive. We would have gotten the same answer in both quadrants. So it feels a little weird to not choose adjacent quadrants, but then you get the same answer for all compositions. And this is just one example where we get different answers, but if you choose 1 and 3, you would get the same answer for both compositions. That's why I personally think that's the better choice, and I'm pleased that our calculus textbook uses that. but our pre-calculus textbook doesn't. So we're going this semester with the pre-calculus definition, so that if we're working with arcsecant, that's going to be the output of that will be an angle that corresponds to an angle in quadrant 1 or 2. But again, that definition will change when you go into calculus. So just a heads up, because that's kind of a confusing thing. It would be nice if the mathematicians could agree, but there are people out there who don't agree with me, and that's very sad because I think I've got the better one choice. Oh well. Okay,